I did this lesson twice with 2 other geometry classes last week, and I'll be honest, I didn't like the way it started out and was set up. So I'm going to get rid of this entire first number 1 here by doing the proof and everything else. With you guys, I just figured the best way to do this is just get after it and show you the rules. Okay, so that's what I'm going to do. So look at example 2 below for me. I want to introduce you to our second and final type of special right triangle. The first one was called 45, 45, 90. Why? Because those were the angle measurements. Here's our next one. I put in a 30, I put in a 90. Can you quickly find what the remaining angle is here? The remaining angle would be a 60 degrees, correct, 60. This is called a 30, 60, 90 triangle, okay, because that's what the degrees are. And their sides are in a special relationship. Before I get into what the rules are, there's still 2 legs, right? There's still 2 legs because it's a right triangle. Do you think they're congruent here? No, because they're across from different angles. But what I need you to be able to do first for me right now is, do you know which leg, BC or AB, is the shorter one? And don't go by looks. Mathematically, how can I figure out which one out of the 2 is the shorter leg, BC or AB? Anybody remember? We went over a little fact. Zach?
The smallest angle is across from the smallest side.
Smallest side across from smallest angle. So what would I label as the shorter leg here? AB or BC? BC. All right, so I just want to make sure we're aware. Shorter leg. And that would make AB what we're going to refer to as longer leg. Longer leg is always across from the 60. Shorter leg is always across from 30. And then AC is still what? That's not going to change no matter what degree measures I put in here. AC is still called the what of the right triangle? Hypotenuse. That's not changing. So is everyone all right? Why I'm calling BC the shorter leg? It's across from the smaller angle. All right, now to the rules now. And I'm just going to give them to you. All right, instead of you guys exploring in your group and coming up, let me give it to you. We need the practice. So in a 30, 60, 90 triangle. Ready? The hypotenuse now, hey, this is where it's going to start getting a little crazy because remember, the only thing you know hypotenuse is leg times radical 2 from the 45, 45, right? Well, it's a new way you find the hypotenuse in a 30, 60, 90. It's going to be 2 times the shorter leg. So you take your shorter leg and multiply it by 2. That's how you find the hypotenuse. All good? How do you find, my second and final rule is how do you find the longer leg, the one across from 60, the longer leg in a 30, 60, 90. Ready? This is shorter leg. You take the shorter leg again and multiply it by, here's where it gets nuts, the square root of 3. Why is this going to get tougher? What was the 45, 45? Square root of 2, yeah. Separate them. Okay, we got to separate them. Square root of 3 is for the 30, 60, 90. So those are your rules. Okay, hypotenuse is 2 times the shorter leg. Longer leg is shorter leg times radical 3. We all good? Are you ready to practice? Simple, 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 tough, tough, tough. That's the order of the problems here. Go back to number 2. Let's go back to number 2. Because we still have to find the other 2 legs. All right, first thing you do, you look at the diagram. This is a 30, 60, 90. What is the 4? That is the Hypotenuse. Write out the hypotenuse rule then. I gave you the hypotenuse. Write out the hypotenuse rule. I'm going to start abbreviating here. Hypotenuse equals 2 times shorter leg. And everyone all right? I'm going to start abbreviating shorter leg SL, so I don't have to keep writing it out. Where's the 4 going into? Here you go. 4. It's the hypotenuse. Equals 2 times shorter leg. How can I get the 2 out of there so I can figure out what the shorter leg is? Divide both sides by 2. So my shorter leg has a length of 2. And again, what is the shorter leg again? Name it. BC. So BC is 2. What's the only one I need to find? AB, which I refer to as my longer leg. Use the rule. Look back. Use the rule. Longer leg equals shorter leg times radical 3. Okay, longer leg. What was my shorter leg we just found? 2 times radical 3. Can I do anything with those 2? No. Just put them together. I don't want a decimal. Just put them together. So your longer leg is 2 radical 3. And what side did we call the longer leg? AB. There you go. So that's how we're going to start using these rules. So this was what? 2, and this was 2 radical 3. Questions from you guys yet? One's not going to make you great. We need a lot of reps here. All right, there's 1. So now let me start calling on numbers now. All right, let's go to number 1 here. Everyone see we identify this is definitely a 30, 60, 90 triangle. What is the 12? Don't say anything. What is the 12 referring to in a 30, 60, 90? What's the 12? 10? That's my hypotenuse. If I'm given the hypotenuse, I write down the hypotenuse rule. Hypotenuse equals 2 times shorter leg. And I know some of you are going to get, oh, I can find the shorter leg just like that. That's fine. But I want to write everything out at first. Plug in 12 for the hypotenuse. 2 times shorter leg. What's the shorter leg going to be after you do your math here, your algebra? 5, what's my shorter leg? Maybe next time. 20, what's my shorter leg here? What is it? 6, divide both sides by 2. Good. 6 is the shorter leg, so this is 6. Now find your longer leg, the other side, because I got to find all the missing lengths. Longer leg equals shorter leg times radical 3. All right, and then what's your longer leg going to be then? 20 again, longer leg. 6 times the square root of 3, which is across from the 60. 6 radical 3. All right. Am I going too fast? Or are we okay? Because now it's really, what side do I give you? You start out with and going from there. So 2. Name the side that is labeled 8. What do I call that side that is labeled 8? Because it is no longer the hypotenuse. We are starting somewhere different now. What's the 8 here? I'm already heard from 20 enough. 11? Maybe not. 18. What is the 8?
Shorter leg.
Shorter leg. That's the shorter leg. So now look. Now I could use either rule, right? Because both rules have shorter leg in it. So I'll do hypotenuse equals 2 times shorter leg. I could have used either one of them first because both of them involve the shorter leg. All right. Plug in the shorter leg and tell me what the hypotenuse is here. What's my hypotenuse? 10, hypotenuse length? 8 times 2, 16. I'll even do that. 2 times 8, hypotenuse equals 16. All right, longer leg. Got to know the rules. Shorter leg times radical 3. How long is my longer leg? 17? 8 times the square root of 3. How we feeling, all right? Yeah, this is all nice and dandy until we got to do something crazy with those radicals. Any issues yet? All right, and next up. What did I give you? What's 2 radical 3? Oh, right. So I got numbers. 8. What's 2 radical 3? Do we have an 8 anymore? I'm on.
2 radical 3 is the shorter leg.
Shorter leg. Use either rule, right? If you're given the shorter leg, both rules involve the shorter leg, so use either one. I'll start with the hypotenuse like I usually do. Hypotenuse equals 2 times now 2 radical 3. Uh-oh. Oh, boy. What's the deal here now? You can multiply them. That's fine. You just multiply the numbers out in front.
Yeah, so it's just 4 radical
2 times 2, 4. Radical 3, and I leave it like that. Done. Everyone all right with that? Algebra with the radicals. Just multiply the numbers out in front. All right, now let's talk longer leg. Shorter leg times radical 3. The shorter leg was 2 radical 3, and I got to multiply it by radical 3. Ready, kids? We can do this. We can do this. Multiply the numbers out in front, just like we did here. 2 times, now I know nothing's there, but we know there's a 1. So we're going to get 2 times, you can multiply those radicals. Anybody remember what happens when you multiply a radical by itself? You get the number underneath, right? So 2 times 3. Now, even if you don't remember that, that's okay. Maybe you see radical 3 times radical 3 is radical 9. What's the square root of 9? Done. Okay? So either way, we're getting here. That the longer leg is 6. Anything from you guys? Because this is, we haven't even hit the hardest ones yet. We all good? All right, next up. What's the 6 radical 2? 17, the 6 radical 2. Write the darn rule. Right? Oh, I have the hypotenuse. Write the hypotenuse rule. 2 times shorter leg. Plug in 6 radical 2. Now it's going to get a little crazy. 6 radical 2 equals 2 times shorter leg. Once again, what do I have to do with the 2 to get it out of there? 1?
Divide each side by 2.
All right, yeah. Come on, guys. Come on. Divide each side by 2. What do you think the shorter leg is going to be equal to? Look at here. Can you cross out the 2 under the radical and this 2 in the denominator? Absolutely not. 1's underneath the radical, but I can do something with the 6 and 2. So the shorter leg, 3 square root of 2. Are we okay before I get to the longer leg? Just divide out 6 and 2. All right, ready for the longer leg. Let's write our rule. Shorter leg radical 3. Shorter leg we just found out was 3 radical 2 times radical 3. Now, if I asked you to add those, no shot, because what's underneath is not the same. But are we adding them? We're multiplying them, which is allowed. You can multiply any radicals that you want. All right, the number does not have to match. So this is numbers out in front. What do you end up with? 3. Radical, you can do it now. 6. I put a plus sign in between instead, no go. But you can multiply anything you want. So there's your longer leg, 3 square root of 6. Questions yet? Trying to go through every scenario here with you. Ooh, this is the first time I gave you this. First time I've given you this. What is this? What is 6 radical 3? What am I giving you here? 21? Longer leg. All right, get out the rule. Get out the LL rule. Longer leg equals shorter leg times radical 3. Plug it in, the longer leg, 6 radical 3, plug it in. Ooh, how are you going to get rid of the radical 3 now to get to the shorter leg? How do I get rid of that radical 3? Oh, 16?
You can divide.
Yeah. Just like we've been dividing 2, you can divide radical 3. And what happens on the left side over here? I got radical 3 and radical 3, so see ya. They're gone. Divide them out. So your shorter leg is how long? 6, perfect. And then hopefully that makes your hypotenuse go even quicker. So go ahead, find the hypotenuse. I don't even write down the rule. I'll just ask somebody here in a second. Eight, how about your hypotenuse?
I got 36.
How'd you get 36? For 5? 5. Shorter leg is 6, right, Molly?
Oh, yeah, sorry. Short leg is 6.
And how do you go from, what's the hypotenuse rule?
Sorry, 6 times 2. Sorry, I got 12.
There you go.
Sorry, I was thinking the wrong one.
It's all good. Questions? 12? And you ready for the hardest one I can give you? A longer leg without a radical 3 with it. Okay, a longer leg without the radical 3. So I already gave it away. I won't ask anybody here, but everyone, I'm giving you the longer leg, right? 12 is the longer leg. It's across from the 60. No problem. We write down the rule. Longer leg equals shorter radical 3. Plug in 12. 12 equals shorter leg times radical 3. Still going to ask, how do I get rid of the radical 3? 19, how do I get rid of that bad boy? Divide both sides by radical 3, but unfortunately, like the last problem, the radical 3's don't cancel, right? You think I can divide these two? 12 over radical 3? Nope, one's underneath the radical. Don't touch it. We do have experience, though, don't we? That we are not leaving our answer as 12 over radical 3, are we? So from Friday, what's the problem with that answer up there? 16, what's the problem with that answer?
You can, what was it? The square root can't be the denominator.
Correct. Can't have a square root denominator. Good job. Somebody else. How do I get rid of it? How am I going to get rid of this thing? 10? Kid wasn't even in class and he knows. Top and bottom by radical 3. Wow, this is just to find the shorter leg. All right, so shorter leg. What do you have on top? 12 radical 3. And what's on the bottom? 3. I'm not even going to accept that as an answer. You better keep crunching. 12 radical 3 over 3. Can keep simplifying. 2. 16.
4 radical.
Thank you. 4 radical 3. Wow. That was just for the shorter leg. I still have to find what? Hypotenuse, yeah. How about that hypotenuse? 2 times your shorter leg. Give it a try. Go ahead, give it a whirl. Give it a try. 2 times your shorter leg. Two times your shorter leg. Hypotenuse should end up being 21. 8 radical 3, yep. 2 times 4 is 8, and you keep the radical right there. 8 radical 3. Wow. How are we feeling here? Gotta take a breather. All right. So now we're at this point. When I give you a diagram that has a couple special right triangles in it, not just one by itself, you have multiple special right triangles. What I'd like you and your group to do, if you haven't done so already and moved ahead, find every single missing angle in that diagram, please. All right, don't worry about the sides, don't touch the sides. I want you to find every missing angle in that diagram. And also, to give you a hint when you need it, triangle CAD. Triangle CAD is what type of triangle? Look at the markings. And what do you guys know is across from the congruent sides? Okay, remember that as you find your angles. Find every missing angle for me. Do not worry about the sides yet. Find every missing angle for me. Don't worry about what parts A through whatever say. Just find all the missing angles. Do we have all our, finish up your missing angles? Talk it over with people in your group. I should take this to another page. There's too much work here. Okay, here are all my missing angles. Bunch of 30s and a 120 there. Any questions? Do you see a special right triangle we've talked about? Name it with its letters. Name a special right triangle that you see in my diagram. Name it using its letters. 17, one special right triangle that you see.
DBC.
What is it?
DBC.
DBC. What type of triangle is it? What type of special right triangle is it? Just name it by its degree measures, remember. DBC.
90, 60, 30.
30, 60, 90, yep. But isn't there another one also in this diagram? This is where we're going now, where you see multiple ones in the same diagram. Name the other special right triangle in this diagram. 12?
ABC.
The big one. What type of triangle is that, Luke?
Also 36.
Also 30, 60, 90, yeah. And I'm not even going to look at what it's going to ask me to solve for. I'm going to find all three sides in both triangles right now, all three sides. So it's 30, 60, 90, meaning it's got a shorter leg, it's got a longer leg, and it's got a hypotenuse. If you haven't done so already, in your group right now, that triangle only, find those three sides. I already gave you one of them. Find the other two. Go ahead, triangle DBC. Find the shorter, longer leg, and hypotenuse. I already have given you one of them. So in your group, first discuss what's that 5 represent. All right, what's that 5 represent? And then find the other two. I'm going to take this slow. So where's the 5 go? What's the other two sides? All right, let me go back to you guys. What is the 5? Other than DB, what type of leg or hypotenuse? What do we got for me? 18?
Shorter leg.
It's the shorter leg is 5. Good. Shorter leg's 5. Use your rules. What's the longer leg? 14? 24. Went to the bathroom. 8. Shorter leg is 5. Longer leg?
The longer leg is 5 radical 3.
And now for more of a challenge. Name the longer leg I'm talking about. What side is 5 radical 3 up here? Name it. What side is 5 radical 3? 22? What's that? One job. Jesus. Killing me with my numbers. 17? BC is 5 radical 3. What's the hypotenuse in this triangle? 12? 10. Name the side that's 10. Name the side that's 10. 1?
CD.
CD. Now, whoa! Right away, whoa! That's got a hash mark with it. So if that's 10, AD, 10. All good. Next, I also had another special right triangle. Now, look at the big right triangle. You only can use sides in that triangle. Which side do you know? Shorter leg, longer leg, or hypotenuse? We actually know 2 of them, don't we? What's the shorter leg up here? 5 radical 3. It's across from the 30, right? Everyone see? Take a look. Here's the 30. Across from it is 5 radical 3. I think you can also find the long. You don't even need to use a rule. You could if you want, but look, here's 60 here. What's across from it? 15. Only thing left, find the hypotenuse. If you haven't already. Using your rules for 30, 60, 90, find the hypotenuse. And the hypotenuse length here would be 19. Finish us off strong. 10 times the square root of 3. Correct. All right. I'm just going to warn you. You get 10 minutes here to start, about 7 minutes actually, to start it. I try my best to make sure the homework is not longer than it needs to be, just enough. But I'm going to let you guys know this homework is a little bit longer than previous homeworks this year. You got to get the practice. Got to get going on it now. Call me over if you need help. Get the answer key out so you know that it's going right. This one's going to be a little longer than previous homeworks this year, only because we need the practice. And there's what your quiz is on, everything so far. Wow.